For this next video, we are going to change some of the connection types. So go back into modeling. And we'll begin by looking at your sheet S2, your framing plan at the floor at 112 0. So let's open up in your model 112 0. And again, to get rid of some of the clutter in the model, let's go to your display options. And in this case here, we still had all the piece marks and stuff turned off. And the only thing that's left that's showing up that's making it a little cluttered is the member end elevations. So let's turn that off, uncheck it, and hit OK. Now, for the connections, as I pan up here and zoom in here a little bit, you can see these little lines showing up. Them are the indicator of your shear bar connection, that it's a shear bar connection, and the side of the web that the shear bar is on. And if you look at your drawings, S2, you can see along this grid line A. Actually, let's clear up one more thing on your display options. Let's get rid of member orientation indicators on all. Let's say none, and hit OK. And that gets rid of the orientation indicators, clears it up a little bit more. So now back to the shear bar locators. You can see on here and back on your plan view, your drawing S2, it's indicating here we need a connection, a shear bar connection. The next one over, next one over, next one over, next one over, next one over. All of them need that shear bar connection. So our connections there are good. But let's go in, zoom in here a little bit closer. Let's go SA for solids. And to make it easier to see, if we go back over here on the right or left hand side to change all solid transparent main. And now we zoom in here a little bit closer. If you remember when we were looking at the model a little bit, navigating around, I said that that connection was not correct. You can see the beam is coming way in here as I zoom way in. This triangular piece here, that is the weld to connect this plate to this beam here, web. Well, my beam setback is not correct. So when we put these beams in here, if I highlight that beam, double click on it, my connection was auto standard. So to show you how to change that, again, we didn't do a whole lot in the setup, but if we go to our options, go to job options to auto standard connections, you can see here's where it gets the auto standard connections from. So a beam, in our case here it's a beam frame into a beam. So frame conditions, beam to beam. And then the type of member, so a channel to a channel. We've got a wide flange to a wide flange. So we pull down our scroll bar here until we get to wide flange. We're getting wide flange to channel, wide flange to tube. Okay, so here's wide flange to wide flange beam. Then you get different options to the flange, a splice connection, to the web at a skewed angle, or to the web perpendicular. So in our case, we're wide flange to wide flange, web perpendicular. If I highlight that, you can see some of the connection information here. The thing that is wrong here is my field clearances. It's on 0 and 0. So if I double click on that, instead of just seeing a preview, now I get my actual options. So my field clearance is here. I want to change this to 1/2 and 1/2. All the other information is correct, but I want to make my setbacks, my field clearances, from the member that it's framing into a 1/2 inch clear. So hit OK. Then if it's a skewed connection, you can see that one was correct. It's at 1/2 and 1/2. Now let's check our beam to columns. Again, we'll scroll down. Wide flange beam to wide flange column. Our connections to the flange coming in perpendicular to the flange are a clip angle, that's correct. And to the web is a clip angle as our auto standard, and that is correct. The other option is that we have on our job is wide flange beam to a tube column. Coming into the flange, what's considered the flange, perpendicular, it's a shear connection at a 1/2 inch setback. And coming into the web, perpendicular, it's a shear connection at a 1/2 inch setback. So that is correct. So hit OK. And now you can see nothing happened. Them changes did not happen. So in order to get the solids and it to create the connections before, we had to process and create solids. So again, let's go to process and create solids. Your options were to go up here to process, create solids, or F5, or here. This icon here is process and create solids. So we'll do one of them, and it processed and created solids, but you can see nothing changed. It still hasn't changed. After you create process and create solids, unless you add members in or do something that modifies the member that it has to process and create solids, it does not know exactly which ones to process and create solids. So in order to get it to make that change, we have to force it to process and create solids. So for example, if I click on this one here and right click, I get some options here. Mark member for processing. So now as soon as I mark it, it loses all of its three-dimensional solids because it needs to process it to reanalyze the connection. So now if I do process and create solids, you can see it came back in, and now you can see it set it back. It looks like it's about a 1/2 inch here on the screen. Now, let's zoom over here to the next one over. This one's still wrong. So again, you can see that when I analyzed it, it only did this one because that's the only one we marked for process and create solids. So the best way to do this is when you go up to process and create solids, process selected members, is we need to force it to reprocess everything. So we can go into our isometric view and put a box around the whole model, and it highlights everything. And then we do right click for menu, mark member for processing, and then do process and create solids. And now it should have changed all of them. If we go back to our 112, again, this was that original one. Here's the next one over. Now you can see that one's changed also. So process and create solids, if you change something in setup, you need to force it to process and create solids. That is why it is important to get your setup correct at the beginning of your job before you do the processing and creating solids. So now let's go back to our connection types. And again, the best way to see this is to be in the stick mode. So if you do stick mode as AS for all stick. And again, we can see our indicators at shear bar connections, shear bar connection. So let's start over here in the corner here. We've got a shear bar connection on your plan views, the shear bar connection's on the opposite side. For this course, I'm not gonna be too picky on which side it is on. In general, you can see this beam here. The shear bar is on the bottom hand, the left end of this beam. It's on, say, the right hand side as you're looking at it, and on the top here, it's on the left hand side. That is so when they put the beam in there, they can put it in at an angle and twist it back into place, and one will be on the near side, one on the far side. And on the outside connections here, again, it's doing the same thing. This one here is on the bottom, and over here they've got on the top, but generally on the outside beams it's the first beam they put up, so it really doesn't have to be that way. On your drawing S2, it shows them both on the far side. So as an example here, if we highlight this beam and double click on it with the select button, brings up the member edit window, and again expand the window size so you can see both left end and right end settings. Okay, here you can see, first of all, it grabbed the vertical brace, so I'm not in the right member. So in order to get the right member here, if we do solids all to get into the solids mode, now you can see I'm highlighting the beam. If I double click on that, I'm in the beam here. So our connection type was auto standard. So SDS is saying a wide flange beam into a tube column, the auto standard connection is a shear bar connection, and our auto standard connections set up for SDS2 to choose the side to put the shear bar. For us to tell SDS2 where to put the shear bar, we can't leave it on auto standard. We need to go and change this to shear on both ends. Then under our connection specifications, as I click on that to open up that window, here you can see shear plate side automatic. Turn that to far and far. Now here we are modifying this connection, so the specification, so if when I hit OK on the bottom of my screen here, right away it turned that member back to stick. So that's an indication that that one has to be processed to get it to regenerate the connections and analyze anything framed into it. So now we do process and create solids again, and I'm gonna do AES for all stick. Now you can see my shear bar indicators on the far side, and on the other side it's on the far side as I'm looking at that member from left to right. So that is the way to change your shear bar connection side. So if you would like to, you could go back to this member here, and I'm gonna go SA for solids all, click on this one here, and we could change that to shear and shear and connection side, far side and far side, and OK. And this one here is shown on the near side, and that one's also on the far side. So I can do the same thing there, shear, scroll down to my connection specifications, plate, far side, and OK. Scroll back out, process, turn it back to stick, AS for all stick, Now you can see my shear bar indicators are on the right side according to my S2 plan. And as I zoom back into here, I'm going to do SA for solids all. And you can see everything is correct here. The shear bars, you can see them now. The setbacks correct. So go back to all stick. This one in here indicates far side, that's correct. Now your S2 drawings show, say at the intersection here of 2 and B, it shows like a clip angle on there. That was just put on there for reference for you to make sure you had the right connection. SDS2 does not show that on here. It only does it on the shear bars because it has to tell the erector which side to put the beam on. Where if it's clip angles, the clip angles are attached to the beam. So here, the way to check these is do SA for solids all, and probably better yet to change all the transparent main, so you can kind of see through the connection. And you can see there's double clip angles here, double clip angles here, and here. So on your plans it says this beam here should have double clip angles and this beam here should have double clip angles, but this one here should not. That should have a shear bar. And then if you see on your plans, it has a triangle, a solid triangle, which defines a moment connection. So let's click on that beam there, double click on it to open up the member edit, and let's create that moment connection. So for a moment connection, you can't have your connection on auto standard. We have to do shear bar again, and change that to shear bar on both ends. Then as I scroll down on my connection specifications here, let's change the shear bar on the, okay, actually, yeah, on this one here, let's look at your sheet S4, which is the elevation at grid line B. On the right end, which connects to grid line 2, that's where we want to use our shear bar connection. And our side was on the far side according to your plan view. On the left end of this member, we are not going to use a shear bar. So our connection type, we are going to use a end plate. And that we will show you here how that creates that moment connection. So now as we scroll down, we have our end plate and our shear bar connection. As we scroll down, you can see moment here. So if we highlight moment, then it's asking you for the moment type. We want on the left hand, that end plate, we want it to be a bolted. And then the location of the bolts, again, it's hard to see on your drawings, but if you look on your sheet S5 with your reference details, detail 18 and 19 show you the moment connections. So detail 18 for that end plate, the location top and bottom and the bolt pattern 8 means there's 8 bolt pattern, and we're saying top and bottom. So that is correct as shown. On the right end, we want a bolted moment, Actually, no, we want a welded moment. If you look on detail 19, you can see the connection to the web of that member is bolted. That's that shear connection. The two flanges which create the moment, they are prepped for a field weld. So we want that welded. And let's hit OK. Now you can see in my model, my triangle showed up for a moment connection. The shear bar is on the far side. And on this end here, it's just the moment connection symbol. There's no shear bar because that's an end plate. So here, let's process. And as it turns back to solid, you can see there's no connection there. And there's no connection here. And that is because of the loads on that moment connection. So let's open up that beam again, double click on it. And let's scroll down to the bottom. And here's your loads. As you go through and try to find some of this information, if you click on the options over here in your tree, it'll take you to them options here. It'll open them up over here also. So loads here. For this course, we are going to lower loads to get connections, some of these connections to work. This is where if your design tells you to design it per half the uniform load, or for your moments, you get your setup and the connections fail, you are varying from the design specifications, and this should not be done without the engineer's approval. So this is a spot where we would use that job standard detail to put on our drawing, so when we detailed our member, that would show up, and we could make a job standard detail that says engineer verify load, and that would show up on our drawing. So for here, again, for the load, let's change this, and let's go to 6 for this moment load. It's a positive 1692. Let's change that to 600. On the other end, it's a negative. So let's go negative 600. And then for the shear loads, let's turn them off auto. And let's go 25 and 25. And hit OK. Process. And now when it recreates the solids, you can see we have a connection. So let's open our view B really quick. And you can see we have a connection that looks similar to your detail 18 on S5 on that end, and on this end, similar to that other detail. Now, since we reduced the loads down to 25, we have a slightly different connection that's shown on detail 19. 19 shows a 4-bolt connection, and we have a 3-bolt. So if I would go back and go back to my load here, maybe we can change this back to 35 and still get it to pass. So it still passes, but it's still only putting 3 bolts in there. So that is how you create the moment connections. Again, changing the loads needs to have prior approval, or you need to put a note on your drawings to have the engineer verify that if you are deviating from the design criteria. So next, let's go back to your plan view at 112. We got that moment connection to work. We go AS for all stick and go back to this upper area here, and again where it's showing shear bars, go through the rest of your drawings here and get them connection to be look like the drawings show. As far as shear bars for this beam, this line of beams across here, actually let's look at this line of beams right here first, this one here. Cancel out there. Let's turn this to solids and opaque, or solids transparent main, and you can see there's no connection here. So let's double click on this beam. Let's go to loads here and change that to 25 and 25. Now in this in this situation here, there are two beams that are identical. You want to change all B19s, quantity of 2. I'm going to say yes because I know it is this beam here and this beam here. And as I do that, you can see they both turn to stick mode again because they have to be processed. So now you can see our shear bar indicators, where they're at, and let's process. And now when I zoom in there, you can see I have my connection. So in that case there, well, the one worked and the other one did not work. That our load was too high. So this one here, that indicator is gone again. This one here, it stayed. So that one's good. This one here, let's open it back up. And loads. It did not change both of them. So let's go 25, 25. And process. Turn anything back to solids, and now you can see that connection's there. Next, let's look at this line of connections here. To look at this line of connections here, let's go to our surface commands and our surface mode. And as I highlight the top of this beam here, I'm going to left click for adjacent. And again, it's showing which side it's going to snap to. I'm going to hit next. Now it's going to snap to this side here. I'm going to hit accept. And again, my depth in and out, change it to like 6 and 6. And now you can see the web of, I'm going to hit escape here to get out of that command. Now you can see the web of all them members and the connections, and as you can see, there's no connections. So on this line of beams here, your plans say for this connection here at 1, shop bolted. Let's double click on that beam, and for your connection, let's clip angle it, because on your plans it's showing 2 clip angles. So clip angle, and then shop bolted. So now, since we're defining the connection, it's not on auto standard, it opens up your connection specifications the next line down, and it's saying gauge, wide gauge. That means 5.5 center of your holes. We're going to leave that as is. Attachment, we want it bolted. And let's leave everything else as is and hit OK. Process. And it's failed. No connection yet. So now let's go down to, scroll down to your loads. And your loads are pretty high for that. It's a short beam. It's only 6'6" long. And our setup is probably set on 50% of the allowable uniform load. So it's saying that beam can handle a lot of load, and it's probably not handling much. So let's go back down to about 25 again and hit OK. Process. And now you can see a connection appears, and it's a clip angle connection, and the connection here to the, this is a supported member, and this is a supporting member, the member that's supporting it, this member. So the supporting member has bolt holes coming through it. That's correct. The supported member has bolts in it. So that's a shop bolted connection. If we would go with welded, these bolts here would disappear, and this clip would get welded to the member. So now we have that connection there. This connection over here has appeared, but it's not the right connection. And it appeared because we lowered the loads. This connection here, let's try finishing this one up here. Here we want to, as your shear bar connection, and again this one's probably failing because of the loads. So if we go to our loads here, again let's change this down to about 25 and 25. Process. Connection there and connection there. Now in this case here, we are snapped to the surface of this web here. I'm going to turn it back to solids all and not turn on the opaque. So here you can see this plate here is on the near side because I can see it. This plate here I can't see it except for just this little edge here, so that's indicating it's on the far side. So again, on your plan view on S2, that's what it indicates. This one's on the far side, that one's on the near side, so that's correct. So now we're down to this connection here. Let's highlight this beam here, double click on it, and we want, on this end here, we want a clip angle connection, and we want it welded. We're going to hit OK. Process. And you can see it made a welded connection, but it's got this other plate underneath it. That's called a web doubler. And again, since these are short little beams, the loads are greater. They can handle more of a load than what they are really handling. So we can knock down the load here. So again, let's change this to 25 and 25. Process again. And now I have a clip angle connection. Your plans show a clip angle connection. It does not say shop bolted. So this one's welded. And then we're over here. Now here, we want clip angle connection on both sides, but your plan says safety connection. So one clip angle is going to be up higher than the other. So a couple options here. Let's try this beam here. We are on the right end of this beam here. this beam here, we're on the left end. And you can tell this is the left end of this beam because as I highlight this beam here, you can see right about here, the circle pop up, that indicates the left end of the beam. Any beam you are on, as you highlight it, that circle indicates the left end. So if I highlight this one, you can't see a circle here anymore because the circle is down on this end. That's the left end of the beam. So you need to know that when you're editing beams. So, because if you flip around to the far side of this beam and think, since this is the left end as you're looking at it, it may not be the left end, it'll probably be the right end. So here, as we look at this then, again back to here is where we want to be. This end of this beam, which is the left end, we want that to be clip angle. And then as we go to expand the connection specifications, we want it to be a safety connection. And we want it to be welded. And then the loads we already have dropped down to 25. This beam here, this will be the right end. We want that clip angle. Scroll down to connection specifications. And we want safety connection. And okay. And we'll process. And this one worked, this one here's failed. Let's change this one back to non-safety and process. And you can see now it has one high, one low. And let's highlight both of them, mark for process, process. And now you have the connection. One's high, one's low, so it's considered a safety connection because if they put this beam in, they can put this bolt in and it won't interfere with this connection. Or if they put this beam in first, they could put that lower bolt in, it won't interfere with that connection. So that should wrap up the connections on 112. We will continue this with the next video.